So they are giving us a tank has a height of 10 feet. The area of horizontal cross sections of the tank. So like if you think of it like a 3D printer, like it's printing it in these slices, they're giving us the area of the horizontal cross sections is given by that function A of H in square feet. That's values in the table. They tell us that it's continuous and that it's decreasing as H increases. So all of these values are always going to be decreasing. So letter A, use a left Riemann sum with the 3 subintervals to approximate the volume of the tank. Indicate units of measure. All right, so left Riemann sum, easy enough, you just write it out. First subinterval from 0 to 2, that's 2. The number on the left is 50.3. All right, next subinterval from 2 to 5, that's a distance of 3. The number on the left is 14.4. And then the last one from 5 to 10, that's a distance of 5. And then the number on the left is 6.5. Now that is in square feet. But if you're adding up all of those slices, you're ending up with the volume of the tank. So instead of square feet, it is going to be cubic feet. So feet cubed. You don't, I know it's a calculator, but you do not need to type that in your calculator to get an answer. Just leave it alone. Just don't do anything. All right, letter B. Does that approximation that we just did, is that an overestimate or an underestimate of the volume of the tank? All right, these values are decreasing, and I usually just draw a line that's going down. So imagine a function that's decreasing. We did a left sum. So when you slice up all of your rectangles, good. It is going to be an overestimate. You're pulling from what's higher up. So overestimate, because this A of H function is decreasing, and this is a left sum. That's everything that you have to say to get credit for it. You have to answer it overestimate because the function's decreasing and we did a left sum. All right, so then they give you a function for f of h that also models the area of the horizontal cross section. So like here we were doing an estimation of the volume in the tank. We were just using some of these values that they gave and did an estimation. Now they're giving us an actual function. We can use the calculator to find the exact volume of the tank. So like this Riemann sum is an estimate. Now we're going to get the actual volume. And so what we want to do is add up these cross sections from 0 to 10. It said the tank was 10 feet high. So we want to do an integral from 0 to 10, not h. From 0 to 10 of this f of h function, dh. All right, so we're going to put that in our calculator and it will give us the answer. So math 9, 0 to 10, and then in there you're going to put this. I know it says h, but I'm going to type x just because it's easier. So 50.3 over e to the power 0.2x plus x, and then dx. And make sure that you do 3 decimal points. It is 101.325. And again, it says indicate units of measure. So again, it's going to be cubic feet. For part A, we estimated the volume of the tank. For part C, we found the exact volume of the tank, but they're both values that represent a volume, so 3-dimensional, so feet cubed. All right, and then last part, water is being pumped into the tank. All right, so the height of the tank isn't changing, but the height of the water in the tank is changing. So it says when the height of the water is 5 feet, this is a related rate. When the height is 5 feet, the height is increasing at a rate of 0.26 foot per minute. So that's dh dt. That's the rate of change of the height with respect to time. And what did that say? Foot per minute. All right, so when the height is 5 feet, that's when we're hitting pause. It's filling up. This is the rate at which it's filling up. So the height, the amount of water in the tank is increasing. We're filling it up. Using this function here from part C, find the rate at which the volume of the water is changing with respect to time. So dv dt is our question mark. It should be positive because the tank is filling up with water. And then again, they say when the height is 5 feet, it's like you already said that. They said that twice. Indicate units of measure. If you get stuck on this problem, make up an answer and put units of measure, because then you can still get a point for that. I'll show you when I go through the points here in a second. Don't just put the units with nothing, make up a number. Put your favorite number and then put units of measure, because then you can still get the point for the units. All right, so we need an equation for volume. volume is the integral from 0 to whenever. And then you're like, but Miss Cole, the height of the tank is 10 feet. Yeah, but we're doing volume of the water that's in the tank, and that's changing. So it's like, yeah, this tank is 10 feet high, but the water height is changing. So your volume of water, not the tank itself, but volume of water is from 0 to whenever of this f of h dh function. And we're going to do the derivative of that. So derivative and integral cancel. That's just going to give you what's inside. So that's just going to be this f of h function. And then you have to chain on dh dt, the derivative of h. So it's this function and then times dh dt. All right, so plugging in what they told us the height was 5. So we're going to plug 5 into this function. 5 is the height. And then times that 0.26 that they gave us for the rate of change of the height. All right, so we are going to plug 5 in for h to this function. So that is 50.3 over e to the power 0.2 times 5 plus 5. All right, so I'm going to hit enter on that. That is f of 5. That's this part right here. And then I'm going to multiply that by 0.26. So we get 1.694. And then we need units. Now, volume was feet cubed, cubic feet. But this is a rate of change of the volume. So it's going to be feet cubed per whatever the time measurement was, and it was minutes. So feet cubed per minute. All right, let me go through what the points are for this one. For part A, it says a point for doing a left sum and then a point for the approximation. I guess the left sum is, did you use these 3 numbers? And then the approximation is, did you get the 2, the 3, and the 5 correct? Either way, that's 2 points if you got that. And I feel like you probably would just get 2 or nothing. You'd either get it or not. Part B is only worth 1 point. So here's the thing. If you left out any part of that explanation, you don't get the point. So if you said overestimate because this is a left sum, they won't give it to you. If you said overestimate because A of H is decreasing and you left off this part, you don't get the point. They don't do half points. You just won't get it at all. So just be really careful. Make sure you write the whole thing. Part C, you get a point for setting up the integral and then a point for typing it in the calculator. And then part D, you get 2 points for this derivative, and that is all or nothing. You either get 2 or you don't. Yeah, so for part B, if you said overestimate because A of H is decreasing and that's all you said, oh, you said the function, I think they would give that to you because there's only one function in play here. Now be careful with that though, because if there were 2 functions that they gave, you'd have to specifically say which one. But here there's only one function that they're talking about. So so I feel like if you said the function, I feel like they would still give that to you as long as you said everything else. At least I would hope so. That seems like that would be really mean. There's only one function you could be talking about. So yeah, it's just if there's more than one, then you got to be careful. All right, this was 2 points for this derivative, and that was kind of an all or nothing thing. If you didn't chain on that dHdt, they wouldn't give you anything at all. Again, it's even, right? And then it was a point for this answer. And then that should add up to 8. 1, 2, 3, 4, 5, 6, 7, 8. The 9th point is for using units throughout. So these units for parts A, C, and D, those are what the 9th point is. So that's why I was saying, if you get stuck on part D, if you get stuck on any part, don't leave it blank, because if you did this perfectly and put feet cubed and did this perfectly and put feet cubed, but you didn't have the feet cubed per minute here, you would lose that units point. So even if you get stuck on something, just make up an answer, like pick your favorite number and put the units, because if they say specifically in the problem like they did here, oh, whoops. Like how they said specifically, indicate units of measure, where is it? Indicate units of measure and then indicate units of measure. They're probably going to make those be worth a point. So just make sure you put it on everything.